Hello Calculus and welcome to 7.1. This is antiderivatives now. So we've done a ton with derivatives. Antiderivatives is actually going backwards. So I hope you enjoy. Make sure you got your 7.1 notes out and let's have some fun. We're going to calculate antiderivatives. We're going to talk about indefinite and actually definite integrals. We're going to do a power rule. We're going to talk about constant, multiple rule, and the sum or difference rule. We're going to do indefinite integrals of exponential functions and x to the negative 1 and a little bit of story problems. So nothing unusual. Okay, an antiderivative is the reverse or the opposite of a derivative. That's how I think of it. Okay, in real life, a lot of times you'll be given where you fall and then you got to calculate how to get back to where you've gone. So I know where I ended up, but how did I get there? And that's what an antiderivative does for us. So now when you're looking at this here, a capital F prime, right, equals f of f. So if my function f, so the derivative of my function equals my function, then f of x is the antiderivative of f of x. All right, let's see if we can put that into some logic here. We're going to use x squared because everybody knows x squared. So fx equals 2x. Then the derivative of fx is, x squared. Then the derivative is 2x. That means x squared and making f of x squared an antiderivative of 2x. So this is this. The antiderivative is x squared. So the antiderivative of 2x is x squared. All right. So what would be the antiderivative of fx equals x squared plus 7? Give this a shot. I hope you came up with the derivative is 2x. Now what's the derivative of this one? And you should have also gotten 2x. The problem here is 2x we have two antiderivatives, x squared plus 7 and x squared minus 9. So we came with the same derivative both times, but from two separate equations. This means when we find this, we got to add plus a constant back here because we don't know what it is. And we'll show you this in just a little bit. Okay, to find the antiderivative, what you do is you take the exponent. So before to find the derivative here, let's just go through this. We have x squared, we multiplied and we subtracted. So you multiplied first, and then you subtracted. An antiderivative is completely backwards. So this is first, this is second. An antiderivative, the first thing you do is you add. So opposite of subtracting. Then the second thing you do is the opposite of multiplication, which is division. All right, let me show if I can show you what this means. The antiderivative of 8x to the 7th. So the first thing we do is we take the 7 and we add 1. This equals 8. That becomes my new exponent. And then I take the original 8 and I divide it by the 8. So now I take and I divide, which gives me 1, because 8 divided by 8 equals 1, and that's my coefficient. So I get x to the 8th. All right, pause and try yours. So now your antiderivative, you should have added 1 to the 4. So you would have gotten x to the 5th. Now you take that 5 that you had and you divide, and that gives you 1. So it's x to the 5th. Technically, plus c. Because there's always a constant after it that we don't know what it is. All right, now let's see if we can show you why that is. Now the first ones we had were x squared graphs, right? And we talked about those, and they were different. And we had a plus graph, which made it go up, and the minus graph made it go down, and x squared is here. Same graph, 3 different locations. So when you're doing this, if you take the first graph minus the second graph, they are only different by some constant variable. So when you do an antiderivative, which is technically an integral. So we're integrating. So this is an integral symbol. F of x dx. So I'm taking the integral of f of x. It's going to give me my antiderivative plus a constant. I know that sounds weird, but it's really not bad. So I want to find the integral of 2x dx. So I have to find the antiderivative of 2x. So I'm going to take the 1, add 1 to it, gives me squared, divide by 2, gives me x squared, plus my constant, whatever it may be. This one's a little different. I wanted to make sure you understood. So now I've got 2ax. The only thing I care about is the x. So we add 1 to his exponent, which gives me the 2, and then I divide by 2, which gives me ax squared plus c. All right, try yours. Yours is with respect to a now, so please be careful. All right, you should have added 1 to the a and divided by 2. So you got a squared x plus c. I hope you see the difference, because now I told you which variable to derive or do the antiderivative of. Okay, power rule. This is just re-explaining. It says you add n plus 1 and you divide by it, adding a c. So now we have to be careful here. We have to rewrite first x to the negative 4. So I add 1 to that, which gives me x to the negative third, and then I divide by that, which is negative 3 plus c. You can leave it this way, or you can rewrite it with the exponent in the denominator. Your turn. I hope you did well. So the first thing you should have said is I need to find the integral of t to the 1/2 power dt. Well, now you got to add 1. So over here to the side, 1/2 plus 1, make that over 1, right? So that's 3/2. So now I've got t to the 3/2. But I have to divide by 3/2, which I don't particularly want to do because I don't want a fraction in a fraction. So what you should do here is multiply by the reciprocal, which gives you 2/3 t to the 3/2 plus c. Because remember, when you multiply by 2/3, this cancels, times 2/3, and we should be able to straight go there. Okay, this one's a little tricky. We have 5x with no x. Well, that really means that's x to the 0 power. So I'm going to add 1, so it's x to the first divided by 1. So it just changes to x plus c. Your turn. I hope you got 16x plus c. There's not much to that one. Next, the constant is what we've already done. I take the derivative and I actually multiply it by the constant. Is what this means. I can pull the constant out front and ignore him and use him last. If you're taking two of them, you can do them individually and then add or subtract them. So I can do all three of these individually. I can do 6x squared first and pull the 6 out, plus the 8x, 8, and this 8x, and then minus the 9, and the 9 comes out. So the derivative of x squared is x cubed over 3, giving me 2x cubed. X is x squared over 2, giving me 4x squared. Remember, nothing here means x, so it's minus next 9x. Don't forget your plus c. All right, try yours. So you should have done the integral of each of these individually. So this would have been 3x cubed over 3 minus 4x squared over 2 plus 5x plus c. Reducing these, you have x cubed minus 2x squared plus 5x plus c. All right, I hope you did fun. These are kind of fun. I think you should enjoy them. All right, a little trick here. Are you ready? We have x squared plus 1 over the square root of x. Now, that's hard to do. So the first thing we need to do is separate these things out because we don't have a product and a quotient rule yet. So we're going to separate these out. So x to the square root of x is x to the 1/2 power. So I'm going to divide each of those individually, the x squared and the 1. Now I can reduce these, just subtract the exponents and we get 3/2. Move him to the numerator. Now I'm ready to take the antiderivative. 3/2 plus 1 is 5/2, dividing by 5/2, or multiplying by the reciprocal. Okay, now I've got to the negative 1/2, add 1 to that, and we got 1/2 divided by 1, multiplying by the reciprocal, plus RC. Not as bad as it looked, huh? All right, now it's your turn. Okay, I hope you took my hint and actually squared it first. And you should have had an integral of x to the 4th minus 2x squared plus 1. And I hope none of you, I forgot my dx up here, distributed like that, because that would have been wrong. You have taken x minus 1 times x squared minus 1, correct? And that gives us this term. Now we integrate all of those. So that's x to the 5th over 5 minus 2x cubed over 3 plus x plus c. Add and divide. Things to remember. E to the x is tricky. Remember, the derivative of e to the x is itself, so the antiderivative is also itself. Also remember, when we had a function in the exponent, we had to multiply by the derivative, so we have to divide by the derivative. Plus c, and now we're on to our exponentials. So a to the x, remember, was the original divided by the natural log of a. Now if I have a k, it's still the original, but now it's k times the natural log of a plus c. Those little formulas come in very handy. All right, so the first thing we're going to do is look at the e. So I got 9e to the t, so I can bring the 9 out and ignore him. Now the derivative of e to the t with dt is itself, so this is et, but now I have to multiply it by the 9, so it's 9et plus c. Okay, your turn. All right, now when you did yours, it was a little bit different. The 9 was with the t, so you know it's itself, which is e to the 9t, but then you got to divide by the derivative of 9t, which is just 9, plus c. I hope you did well. Okay, exponential. Now remember, exponential is the original, so this guy goes up. Now you take the derivative of negative 5x, which is negative 5, times the natural log of the base, which is 2, plus c. Okay, pause and do yours. So you should have had 3 to the 4x, all right, times the derivative of 4x, which is 4, times the natural log of the base, which is 3, plus c. Don't forget those plus c's. They can cost you a lot of points on the test because they are extremely important. You do not know exactly on the graph where it is, and the plus c puts it where it needs to be. Okay, last but not least is this dude, because he's a little hard. If you add 1 to negative 1, you get 0, and you're in trouble. So this is a special rule. You know that 1 over x is the natural log of the absolute value of x. The absolute value is there because it has to be positive. Remember, we cannot take the natural log of a negative number. Plus c, of course, for our constant. So let's rewrite these both first. So we rewrite this as x to the negative 1, so he's the one we just learned. And we still have e to the negative 3x, nothing different there. So x to the negative 1 is that natural log of x times the 3. This one here is itself, because he's e, divided by the derivative, which is negative 3, plus c, and we are done. All right, pause and try yours. I should have given you more room on this, and I apologize. So rewrite him first. Negative 5, x to the negative 1, plus e to the negative 2x, all dx. All right, so we just did the rewrite. Now the antiderivative of this is the natural log. So it's negative 5, natural log of x. All right, next we have to do the derivative of e, which is itself, divided by the derivative of negative 2, or antiderivative, I'm sorry, which is negative 2, and don't forget your plus c. I would really like you to bring the negative up here, so like you rewrite this, I'm going to go down, negative 5, natural log of x, minus e to the negative 2x over 2, plus c, but I will take both answers, they are both correct. I just want to make sure you're keeping track of your negative signs. Okay, application. I'm going to use an antiderivative when given marginal revenue to find revenue. So I'm giving you the derivative. I want you to find my original revenue function. All right. It's also used to find speed when given velocity. So if I know velocity is the derivative of speed equals st squared minus 8t. So in order to find my speed, I had to take my velocity, which is 6t squared minus 8t, and take the antiderivative because that's what's going to give me my speed. which is what I need. So I take my antiderivative, so 6t cubed divided by 3, reduce that to t cubed, minus 8t, so that's squared divided by 2, reduce that to 4 plus c. This is my speed equation. Now, we're going to give you some more information. I would like you to calculate c, so I want to find out what this linear part is, if I give you s equals 5 when t equals 0. So my speed is 5 when time is 0. So I'm starting off at 5. We plug in our 0 and c is 5. We rewrite my equation. So remember, this is speed with my correct constant, which we found here. And that's the speed equation for that velocity. I think that's kind of fun. All right, good luck on your homework. Make sure you post questions if you have any. Have a great day.